Hello, everyone. My name is Mary Wells, and I'm so proud and privileged to be the Dean of the Faculty of Engineering here at the University of Waterloo. I delivered this lecture at Reunion on June 1st, 2024, in front of a live audience of engineering alumni in the Engineering 7 building on main campus. However, due to poor sound in the lecture hall, I am re-recording my lecture for you today, which will ensure that my video lecture is of the highest quality for you. Thank you so much, and I hope you enjoy this lecture. And I really thought I would start the lecture with a little bit of the history of the founding of the University of Waterloo in 1957, and really to give you a sense of what was going on in the world at the time, and in particular, what were some of the motivations for the beginnings of the University of Waterloo, and really to give you a sense of what was happening around the world. The Russians were getting more and more advanced in technology, and in particular with the space race. On October 4th, 1957, Sputnik 1 was the very first artificial Earth satellite that was launched by the Russians. And at that time, when you look at it, I'll just play this. And so it was in this context that, back here in Kitchener-Waterloo, Ira Needles, who was then the president of BF Goodrich Canada, made an impassioned speech in August of 1956 to the Rotary Club in Kitchener-Waterloo. And the title of his speech was Wanted, 150,000 Engineers and Technicians, ... the Waterloo Plan. And it really outlined his vision for what was needed to help Canada in terms of its economic development and to ensure that we would not lose our edge in terms of the design and development of technology for the future. And, Needles really, in his Rotary speech, offered a different kind of approach to education that would include studies both in the classroom and training in industry that would eventually become the basis of the cooperative education program at the University of Waterloo as we know it today. And Needles really suggested in the speech that universities and industry should work together to fill the growing need for skilled graduates that would be needed in Canada. So it was a very bold ambition. And really, it's amazing for me to think right now that just a year later, in the summer of 1957, the University of Waterloo was founded. And over on the left-hand side, you can see a picture of Jerry Hagee, who really became the first president of the University of Waterloo, with a map showcasing probably what he and others had envisioned for a plan for this new fledgling university. And really, the engineering became the very, very first faculty at the University of Waterloo. And on July 2nd, 1957, 74 brave engineering students started their program at this new university that was taking a very different approach to education that included combining academic education in the classroom with industrial training in the workplace. And so it was later that year in October that they went out. They started their very first work terms in what was really the first cooperative education program in Canada. And this idea of alternating academic study with practical work experience. And over on the right-hand side, you can see how the campus started to develop. And that's really an overview picture of Engineering 1 and what it looked like in 1958. So it was really kind of some farmer agricultural area that eventually became the university as it is today. And so I really just wanted to go through how we started to give you a sense of our origin story and where we are today. So we started in 1957. There were really 5 founding programs. You can see them listed here: chemical engineering, civil engineering, electrical engineering, mechanical engineering, and engineering physics. And we started with 74 male students at the time in that program. Where are we today now? Well, today we have 8 academic units. We've got 6 wonderful engineering departments. We also have a School of Architecture, which is at our Cambridge campus. And we also, our most recent academic unit is a Conrad School of Entrepreneurship and Business. We've extended from those 5 founding programs to now offering 15 bachelor degree programs and also 54 graduate degree programs today. So we have really grown extensively over the past 67 years. In terms of the student numbers, we saw that we had started with those 74 male students. Today, we have close to 8,900 undergraduate students. About 12% are international students. We have just over 2,000 graduate students, close to 340 faculty members, 240 staff, and 57,000 alumni. So if we go back to Ira Needle's first dream of the Waterloo Plan, 150,000 engineers, we're about a third of the way there. The other remarkable achievement is that Waterloo is ranked as a top 50 engineering school in the entire world. And that's based on the QS World University rankings. I think the most recent rankings place us at number 38 or something like that in the world. This is an exceptional achievement for a relatively young university that started off its path in a very different trajectory in terms of what it was hoping to do with its graduates. This just shows you the program growth over the years. And on the left-hand side, I've listed the founding programs of chemical engineering, civil engineering, electrical engineering, mechanical engineering, and engineering physics. And again, you can see kind of how our physical infrastructure has changed from the building on the top kind of furthest left-hand side to now 2024, some of our newest buildings, Engineering 7, which is where we are today, or where we were in reunion when I was delivering this lecture live. You can see the program growth over time and the introduction of some of the different departments and units from 1967 all the way up to 2018, and some of the development of the new programs that we're offering. The programs I've highlighted in purple, so you can see geological engineering, software engineering, mechatronics engineering, nanotechnology engineering, biomedical engineering, and most recently architectural engineering. I've highlighted them because these programs are really a collaboration between some of our existing disciplines or traditional engineering programs. And so it's a really interesting way that Waterloo has developed these new areas and these emerging areas of engineering disciplines by combining some of the traditional areas of engineering into new varieties of engineering that can be studied. I also just wanted to plot to give you a sense of the growth in the University of Waterloo in terms of the number of students over time, and overlay this with the changes in our physical infrastructure to accommodate that growth. Now, these are the overall students within the University of Waterloo. So you can see we're a university that's getting close to about 40,000 students. And from the very beginnings in 1957 to basically where we're at today, and you can see really that we've been almost continuous growth up until about the late 1990s, where there was a little bit of a dip for a period of time. And then most recently in the 2000s, quite a bit of growth. Today, we saw a little bit of a bulge upwards during COVID because of the uncertainty around the enrollment. Our faculty of math did let in about 1,000 extra students to make up for any other shortfalls we may have. And again, you can see the development of and growth of all of our different buildings on campus, with our most recent being E7, which was opened, I believe, in 2019. And I've put off into the future E8, as we are hoping in the next few years to think about the next building that we may be able to put up. I did mention that in our undergraduate programs, one of the ways that we have realized and aligned ourselves with emerging and important areas of engineering is to combine and create programs through some of our traditional engineering department structure. And so you can see, for example, our newest collaborative undergraduate program is architectural engineering. In fact, we just had our first cohort of graduates last June, in June 2023. And that's really a combination of elements within our School of Architecture with elements from our Department of Civil and Environmental Engineering. Biomedical engineering, which is the next most recent, is really and draws on elements from chemical engineering, electrical and computer engineering, mechanical engineering, and systems design engineering. Similarly, geological engineering, which is probably our oldest collaborative program, is a combination between our Faculty of Engineering, our Civil and Environmental Engineering program with our Faculty of Science, and then mechatronics engineering is between mech, ECE, and systems, nanotechnology engineering, chemical, ECE, and our Faculty of Science, and then software engineering between electrical and computer engineering and our Sheridan School of Computer Science in our Faculty of Math. So it's been a really nice way to develop some of these newer engineering programs. Again, here's just some pictures of the campus in the early days, and you can see really, again, just a series of farm fields. We can see some of the newest buildings that are still around today, although they do need some work in terms of the maintenance for them. And to the growth and the changing of our physical infrastructure to what it looks like today we can see E5, E7, and E6 located there. They are some of our newest buildings. This is just an overview of what the campus looks like today. So in sharp contrast to what it looked like about 67 years ago. And you can get a sense of the growth of the campus in terms of its physical infrastructure, as well as the students, the growth in the number of students that we educate. This next picture is really a picture of our satellite campus, our School of Architecture in Cambridge, Ontario. It's about a 30-minute drive from our main campus here. It's a beautiful building that was an old silk factory that was converted in 2004 to our School of Architecture, and it's a wonderful building. And we also have a campus, a satellite campus in Rome, and that's really a wonderful place of study for our architecture students who spend their kind of final senior year in the fall term in Rome, studying and touring around and getting immersed in some of the architecture in that context. The other thing that has changed over time is the interest in our student design teams. And some of you may have been on student design teams when you were students here. But when we first started and we were really constrained with space, we only had 2 or 3 teams, predominantly kind of in the automotive area where external competitions were being run. The Waterloo engineering students really wanted to participate and did very, very well. And so when the former dean, Adel Sedra, who's in the middle of this picture here, came to Waterloo, he said, we need more space. These student design teams are wonderful. And so when we built E5, we did dedicate a whole floor to our students, our students in particular, creating the Sedra Student Design Center, which is a beautiful and wonderful space to allow these student teams a place to do work in a very collaborative sense. And I will say these spaces are some of the envy of other engineering programs across Canada and North America. And many people have come to look at how we have designed the space because it has been so successful and mimicked it back in their own home units. And, you know, we went from sort of 2 or 3 teams that were first formed to now having close to 40 student design teams. And we have over 1,800 students that now participate in some of these co-curricular offerings in terms of some of the student design teams that they can get involved in. In terms of the undergraduate update, I just wanted to give you a sense. One of the things that we are most proud of is the development of a new tradition within Waterloo Engineering. We started this tradition in September 2023, and it was really a way to bookend the engineering student education so that when they started their engineering education, we would be providing them with an iron pin to remind them of their responsibilities and obligations and ethics as an engineering student. And that's then bookend with the iron ring at the other end. Because we have more than just engineering in our faculty, we decided to call it a Waterloo Engineering Pin. Most of the engineering students refer to it as their iron pin, but it's really more broad than that. And it was really a lovely effort in co-creation between the undergraduate students and some of the senior members of the faculty to really carefully think about what are the values that we hold as a community and what are those values we want to communicate to the newest members entering our community in the form of these first-year first-year students, I should say. And so we came up with 4 pillars that represented these values, and they center on first and foremost community, secondly, responsibilities, the responsibilities you have to yourself, but also to your community. Thirdly, innovation, and finally, excellence. And we felt that these 4 words captured and these pillars captured the values that we felt distinguished us as a community and that reflected back to us what we felt our community was all about. And the lovely thing is we did it with the students. And so it wasn't only a pin, but it also became a pledge that the students could sign on to if they wanted to create a visual representation of these different attributes. We did have an expression of interest for people to apply, and we got back a number of wonderful, wonderful submissions. The final one we did choose is represented here, and you can see you can see the pin and what it looks like. And really, it was done by a fourth-year mechatronics engineering student, Gordon Fountain. And really, the pin's outer ring honors the heritage of the Canadian engineering iron ring, so the circular shape of it. In the interior, we've got, he felt it represented a compass, an internal compass for us, and that the water droplet shaped compass needle and represented that part of the compass, and the four outer ripples that you can see signify the potential impact of our work on the world, so that it may have bigger effects and ripple effects on society that we do need to consider right from the start. The center placement of the compass notes the internal value we owe to ourselves. And finally, the hard hat sits above the compass to extend our personal accountability to include our public responsibility, and that the safety of the public is of paramount importance. And so we did do 24 different pin ceremonies to make sure that all of our first years had a chance to look at the pledge and see if it was something that resonated with them, and also receive a pin. And we see many of the students wearing the pin today. We also wanted to give a chance for our upper years to also get a chance to receive the pin. And so this is a tradition we will continue on with. And in fact, we are getting a very large representation of this pin. I think it's 2 feet in diameter, that's being machined right now and will be placed in the CPH foyer. So when you come back for your next reunion, you can go by and take a look at what that looks like. In terms of the grade averages, and this is something that we have talked about over time and how this has changed, but this is looking at kind of the fraction of our students that had different grades over time and what has happened. And so you can see the kind of darker purple bottom bar represents those students that have grades, average grades between 90 to 94%, and just highlighting the most recent year, 2023, and how it's changed over time. And then the lighter bar represents those students that had grades that were greater than 95%. And so the really, really good news is Waterloo Engineering continues to be a destination of choice for outstanding students, and that we have the very good problem of having a very, very strong, deep, and high quality applicant pool. And so just to give you a sense of that, in our last application cycle for entry into fall 2024, we had over 15,000 applicants wanting to study at our within Waterloo Engineering. We can only take about 1,800 of them. So it becomes a fairly competitive application process. When you look at this graph, you can see, you can get a sense of, what fraction of the applicant pool had marks in those ranges. And so we clearly have a large portion of our applicants having more than 90%, and a very significant fraction also having more than 95%. And so it's difficult then to choose, if you have a 93 or a 94 or 95 or 96, how different are the applicants? So in addition to the marks, we also look at something called the academic information form, which provides additional information outside of marks to let us know what are the other things you're involved in, what are the other things you're interested in. Could be athletics, could be music, could be drama, could be community volunteerism, but we want to see and accept people that do more than just study and that are able to combine their studies with other aspects. I will note that during kind of 2021 and 2022, you will see much higher fractions of the portion of our applicant pool that had grades greater than 95%. I really do believe this was a function of COVID and the fact that students were learning online, taking exams online. And so we've seen now that in this past applicant cycle, we're back down to kind of more normal levels of the lower fraction of the students that have the absolute highest marks. So this is just looking at first year enrollment by undergraduate program. And this is just looking at one of the things that we're interested in looking at. So again, if we go back to the very beginnings of Waterloo Engineering, we started with 74 men in some of our engineering programs. Today, the makeup of an engineering class is very, very different. We're very, very pleased to be one of the leaders in Canada with some of the highest numbers of women in engineering and studying engineering here. And so last year we had 37% of our class being kind of the first years did identify as women. And you can see the breakdown based on the different kinds of engineering programs that they were interested in studying. Clearly, some of the highest levels are things like biomedical engineering, where in fact the class was overrepresented with women, just over 70%. We still see that in some of the disciplines, things like computer engineering, electrical engineering, mechanical engineering, and mechatronics engineering, we have some lower numbers in terms of the percentage of women in these programs. They tend to represent some of the largest programs that we have in terms of the number of students. So this is still an area of active outreach to talk about the opportunities for students of all diversity in these important engineering disciplines. I wanted to give you a sense of the where the co-op placements were across the country in 2023, and this just gives us a sense of where all the students were studying. And again, maybe a little bit different than your experience, we do see that students are working all over the world for their co-op education. And so just to give you some numbers, in 2023, we had just over 2,600 employers. We were placing about 10,000 co-op students in that year, and the total earnings by co-op students in 2023 was just over $128 million. So this is a huge operation. If we think about it in terms of the scale of where we're at, we are the largest research-intensive university that offers a cooperative education program at this scale in the entire world. So we are really offering what I would say excellence at scale is. This just gives us a sense of the breakdown of our international undergraduate students in terms of the top 5 visa countries. And this is from 2023 in first year. And really, we don't have a significant fraction of international undergraduate students. It's kind of in the area of about 11 to 12%. If we contrast that with something like UT, which is more at 40%, we tend to be on the lower end. I think this is a reflection of the difficulty in the early days of recruiting international students into a cooperative education program because of their difficulty to get work permits to work in Canada. And so this is maybe why we are a little bit behind some other universities in terms of the number of international students we have. But the opportunities for our Canadian students to have some form of a global experience, whether it be going on an academic exchange, going to work on a co-op job in another country, or sitting next to a student in class that comes from a different country. I just think in terms of the development of the whole students, this is so important in terms of their own personal and professional development and understanding a little bit more about the world around them and developing what I would call kind of cultural competencies for the future, because much of our work will be done in kind of a global landscape. So I just want to kind of change tracks a little bit and talk about graduate studies. And again, similar to our undergraduate programs, we have developed a series of collaborative specializations in our graduate programs. So we do offer kind of master's degrees, master's of applied science degrees, master's of engineering degrees, PhD degrees. So these advanced degrees in basically all of our engineering programs. But in addition to that, in some areas of research intensity at the university, we also offer a collaborative specialization. And so I've just given a couple of examples here. And so you can see our most recent collaborative specialization is in the aeronautics area, aeronautics program. So you can see that this is a program that is touching all of the faculties across the University of Waterloo. And with engineering, we have a number of departments that specifically are involved in this program. And so as a systems design engineering student, you can get a PhD or a Master's of Applied Science in Systems Design Engineering with kind of that collaborative specialization in aeronautics. And so mechanicals involved in this, electrical and computer engineering, systems engineering. Similarly, when we started our undergraduate nanotechnology engineering program, we realized that we also needed to be able to offer a specialty in nanotechnology engineering. So again, this is a collaboration between engineering and science, and you again can get a Master's of Applied Science or PhD in some of our engineering disciplines with a specialization in our nanotechnology engineering program. Similarly, we've got a specialization, a collaborative specialization in quantum as well as water. And so that's just a different way that we can showcase some of our signature research areas and specialties. The exciting news is that coming in the fall of 2025, we will really have our very first biomedical engineering research-based programs. And so we will then be able to offer graduate degrees, a Master's of Applied Science, and a PhD in biomedical engineering. There's huge demand from the students and our faculty for this program. It really is an extension from our very, very successful biomedical engineering undergraduate program to extend that now into the graduate program. It's the first time we've done a collaborative program between the departments of engineering and the Faculty of Science and Faculty of Health to create a standalone kind of graduate program that has a different name than any of our other degree programs. And the first enrollments are expected to occur from Waterloo transfers that are currently studying Masters of Applied Science or PhDs that are in kind of existing home departments. The other thing that we're really excited about is a new kind of professional or course-based master's program in the area of health technologies. And so that kind of mirrors many of our graduate programs on the research side, having counterparts in kind of the course-based side in many of our departments. And so this will be kind of interdisciplinary and across the university, but then have different flavors related to this health technologies. So the professional master's provides kind of, you can think of it in terms of the breadth component, the depth component, and the integrative component, which could be capstones or co-ops and things like that. And so we're gonna offer this MEng, which will be 8 courses plus a co-op term in 5 of our departments. And so we're very, very excited about this program and hoping to launch it, I hope, January of 2025. The other thing that we've done at the graduate level is really to focus in on opportunities for our graduate students to engage in entrepreneurship. And this has kind of manifested itself in 3 distinct ways. A couple of years ago, we started what we had called the Entrepreneurial PhD Fellowships. And this was an opportunity to provide a fellowship to our PhD students that were working not only in engineering, but across the university in areas where their research could be commercialized, and that they were business-minded doctoral students that were maybe interested in starting their own company or starting a venture. And so because we are so fortunate in the Faculty of Engineering to not only have engineering departments, but also a Conrad School of Business and Entrepreneurship that we're offering kind of programs related to entrepreneurship, why not pair those 2 things together and give our PhD students a chance to do that? And so for the past 2 years, we have been awarding up to 10 PhD entrepreneurial fellowships, which allows our PhD students to not only pursue their PhD or their doctoral studies, but also pursue a part-time MBET degree, which is a Master's in Business, Entrepreneurship, and Technology. And this is a degree offered by our Conrad School of Business and Entrepreneurship. And so far it's been incredibly successful. We've had a couple of the engineering students that have already received considerable investment and considerable success. And the picture down below on the left-hand side is of Kelly Zhang, who is looking at building an AI startup. She's had millions invested in her company, and she's really looking at using AI and imaging of ocean floors to look at the development of some of the seaweed and algae. And it's called Carbon Coastal. And so she's actually been so successful, she's temporarily paused her PhD and her MBET to go out and help build the company a little bit more. And in terms of the significant interest and investment. And then on the bottom right-hand side is a company called LoopX, which is a wonderful PhD student. He's in fact graduating this June, from mechatronics engineering, that was looking at autonomous vehicles. And before he started the MBET, he was thinking of using these autonomous vehicles to go get pizza for them when they were hungry and deliver it back to them within the university plaza. But then when he started the MBET, they really caused him to think differently about the venture he was creating and the opportunities. And he was thinking beyond pizza to, well, what about all the mining applications in Canada and the need for these autonomous vehicles? And so LoopX is a startup company founded by Chow Yu, and he is looking at autonomous driving for underground mining, and again has been very successful with it. And then the other thing that we have been looking at, and this is a new experiment, we have our very first student in this program as of this May. So he just started like a month ago. Drew Davison, you can see him kind of on the top right-hand side. And this is something we're calling a deep tech PhD opportunity, which is looking at entrepreneurs that have already started ventures and companies that are out in the world or in Canada. But in order to advance the technology, which is in a deep tech area, they need to overcome significant scientific hurdles. And so in Drew Davison's case, he's really trying to reimagine the kinds of materials that are used in firefighting clothing, so that they are less carcinogenic. And Drew, the story for Drew is he has a mother who was a firefighter, and so he grew up seeing the kind of equipment she had to wear as a firefighter. He did not know as a child that when you looked at the health outcomes for firefighters, in terms of cancer occurrence, they were much higher than the other population, in large part because of the materials they had to wear to protect themselves from fire. So it's a wonderful story to look at ways to reduce cancer risk with new firefighting gear. And his big scientific challenge is what kind of materials or how can he change those materials to continue to be fire resistant, yet not as carcinogenic for the firefighters that are wearing them. And then finally, we last year in September 2023 engaged with Simon Fraser University on a program they have called Invention to Innovation, Eye to Eye. This is a program that's being funded by my tax around training of graduate students, postdoctoral fellows, and faculty members in entrepreneurship. So it's a free program that gives them a taste of what entrepreneurship is so that they can think about commercializing some of the research that they are engaged in. The other thing we have been doing is that we've continued to run our Students at Risk program and fund. And so we are welcoming 31 Ukrainian students to our campus this summer. They've just arrived about a few weeks ago. 20 will be in what we call the research stream and 11 in the industrial stream. Our partner WSIB has been taking some of them in to help them work in their industry. And then we've also started something called the Rising Stars program, where we've invited 12 Canadian students to join us at Waterloo. And these are senior undergraduate engineering students to think about what research might be like and to give them a research experience with some of our researchers in the hopes that they may consider coming here to do graduate work in the future. And so we'll see how this program goes. Both sets of students have been wonderful. Last year, when we ran our Student at Risk program with Ukrainian students, about 85% of them continued on to do graduate work with us. And so it was a major advantage for us to be able to have access to such a high quality pool of senior undergraduate students that were interested in doing graduate work later on. I just want to touch a little bit on research at Waterloo. I'm not going to spend too much time on research because after my talk, you will have a wonderful opportunity to meet 5 of some of our newest faculty members and hear about the amazing research that they are engaged in. But when we think about some of the emerging areas of research, you can see them listed here, whether it be in kind of next generation communication technologies to future cities. And I must say, we did have some very exciting news a few months ago where Kai Van and Frank Kairos, who is an alum from Waterloo, has decided to invest $10 million in the University of Waterloo to create a Future Cities Institute. And although this touches the entire university, it is really being led by the Faculty of Environment and the Faculty of Engineering. And so we are going to be helping in that initiative, both in terms of research, but also the development of new educational programs. The whole area of health technologies. We have a real strength in robotics. And for those of you that were visiting us in person, I hope you got a chance to see our Robo Hub. It's a wonderful facility looking at energy storage and batteries for the future, sustainable resources, including water, AI and machine learning, and additive and advanced manufacturing are just some of the areas I would say that are emerging and strength areas for us in research. And this is just one example where we look at some of the work that's being done to use AI as a tool to improve building energy use and comfort. And this was just a new study from Waterloo researchers, some of them in our architectural engineering program, to create climate change proof buildings using AI and deep learning powered inspections to see, well, where is the heat being lost in the buildings and how can we use some of those imaging and maps and knowledge to help improve how buildings are being heated and how energy is being lost. I mentioned the Future Cities Initiative with a $10 million alumni investment. And, this is really looking at a future lens in urban focused research, knowledge mobilization, instruction, and civic engagement. And so we're very, very excited about this possibility into the future. The other thing we started about a year and a half ago, is looking at the whole area of trust in science and technology, and it's a scholarly network. So we're looking at it from a research lens, but also trying to engage with the public so we better understand what are the elements and aspects of the technologies we're designing and developing, or the science we are discovering and communicating, that go into the public trusting the technologies or the science and the information they hear or not. And I just think this is so critical because, if we think about the next generation of engineers we need to educate, technology will become more and more pervasive and more important in our lives. And as engineers, we do have a duty to public safety, and we do have a duty to make sure that we hold the highest ethical standards in the technologies we design and unleash on the public. And so I feel the more we can learn about what some of these factors are, and the more we can embed these concepts into how we educate engineers for the future, the better off we will be in terms of our engineering students knowing right from the start what some of these variables and factors are, so that as they're designing these new technologies and developing them, they will have those principles, they will hold those principles very closely in that preliminary design work. And this just shows you some of the different factors that go into, or affect the trust the public has. So we've been running a number of public lectures and starting to do some kind of interdisciplinary research related to this. In terms of entrepreneurship at Waterloo, just highlighting Baylis Medical as 2 very, very successful alum that went off to start Baylis Medical, and it just got acquired. And so they've been very, very successful, and we're very proud of them. I would say that entrepreneurship is one area that really distinguishes Waterloo, the University of Waterloo, from other universities, and maybe more importantly, Waterloo Engineering from other engineering faculties. We have some of the highest percentage of graduates that go out to want to form companies and to try out their hand at being entrepreneurs and things like this. And so we are really the top entrepreneurial university. And just to give you some numbers, and these are some indicators, I guess, that would support this view. We have 4 unicorns, and these are billion-dollar private companies that were created by engineering students and our alumni. We are the #1 venture capital-backed student entrepreneurs in Canada in terms of these venture capital companies coming and wanting to invest in our students and their ideas. 27 billion is the funding raised by Waterloo alumni started companies. That's a huge number. And we have over 1,000 companies created by Waterloo engineering students, faculty, and alumni. And it's a number we're very proud of. Part of that is related to, I think, our unique intellectual property policy, which really is quite different from anywhere else in Canada or even many parts of North America or the world, where it is creator-owned IP. And again, going right back to our roots, this is something right from the start. Ira Needles and Hagee said that was very important in terms of how we were founding ourselves as a university. This is another graph that I saw that was developed by a professor at Stanford University, and it really just shows, you know, where are the US unicorn founders coming from and studying at. And when you look at this graph that he shows, looking at the map of Canada and what universities are producing these founders, he found that more than 20% of the US unicorn founders did study at the University of Waterloo. So that's not just within Waterloo Engineering, but across the University of Waterloo. And I think this is another indicator of our strength in the area of entrepreneurship, and that the experiences we give our students and the diversity of experience leads to them doing exceptional things in the entrepreneurial landscape and having incredible success. As I said, we do have an academic program or an academic unit called our Conrad School of Entrepreneurship and Business. We are really the only engineering faculty in Canada and across North America that has an embedded business school. And so that really gives us some nice advantages. It's a relatively small unit, but you know, in terms of their impact on our programs, we do offer an undergraduate option in entrepreneurship with their support. They do offer their own degree, a Master's of Business, Entrepreneurship and Technology. They are now have just launched their PhD in Entrepreneurship and Organization, and we should be welcoming our very first students in this program in September of this year. They also offer a graduate diploma in business entrepreneurship. And as I described earlier, they've been involved with our entrepreneurial PhD fellowships in terms of giving those PhD students a chance to do a part-time MBET degree. Just want to change tracks a little bit and talk a little bit about what we're doing around engineering equity and diversity, and to give you a sense of it. And I guess from my perspective, what I really want to do is create equality of opportunity for any youth or, you know, the person that is passionate about engineering and has the motivation, the desire, the internal motivation, or intrinsic motivation, and the academic ability to be able to pursue engineering. And we do still see that engineering is underrepresented with a number of significant populations. And so we've invested, you know, significant resources, I would say, to do outreach to allow youth in those underrepresented areas to see themselves and the possibilities for themselves as future engineers. And so one of the things we've done is in terms of Black youth outreach, because we still see that based on the demographics in Canada, we still in Waterloo Engineering are underrepresented in Black engineering students. We've had a partnership with Brainstem Alliance and the Caribbean Canadian Association of Waterloo, and we've been running a very, very successful program that has been recognized with some awards called STEM Powered, where we invite Black youth onto campus. They're mentored by Black engineering students and Black professors as part of the mix of who mentors them and teaches them, partly so that they can see who they could become in the future. The other thing we've done is when we look at our faculty complement, we see that we have very, very few Black faculty members. And so in January 2021, we started a new exciting PhD initiative called the IBET PhD project, which stands for Indigenous and Black students in engineering and technology. IBET, like we're betting on them. where we provide fellowships to Black and Indigenous students to complete a PhD in engineering. And the program has been so successful that it's not only offered at Waterloo, but 19 other Canadian universities. And now I believe we have close to 60 Black and Indigenous students completing a PhD that might never have done that because of this program and the fellowships we offer. And this is just a picture of a conference they were involved in a couple of years ago when we were hosting something at Waterloo. And over on the very far left-hand side is Dr. Tiz McConan, a professor in chemical engineering, who was the inaugural director of this IBET PhD project and has just done a wonderful, wonderful job. Last year, we were so excited to have an investment by the McCall McBain Foundation in the order of $200,000 that would provide more wraparound supports for these students, allow them to attend conferences together, and creating network and mentorship opportunities for them. So it's a really exciting program that I think will disrupt the pipeline of people we can hire for academic positions into the future. The other thing is, our commitment to an inclusive community, a community where everyone feels they can belong and they can bring their authentic selves and not have to worry about things like the imposter syndrome. So we have invested in enhanced wellness supports. We've done, very tangible things like created gender inclusive washrooms. In our space here in E7 and E5, we have Indigenous garden spaces. We have dedicated prayer rooms. We have kind of a land acknowledgement when you first come into E7. We are starting to have some artwork on our walls to represent some of our Indigenous history and the history of our land. The next thing I want to talk a little bit about is Strategic Planning 2024. When we look at our cycle of strategic planning, and when I started as Dean in 2020, we had just started our strategic plan that had been designed by my predecessor, Dean Pearl Sullivan. And so we are now coming to the end of that plan in 2020, at the end of 2024, and we will be launching our new plan, which will go from 2025 to 2030. And so really, when we think about, our plan from 2020 to 25, our vision really went into 5 different pillars, looking at undergraduate learning and the experience. And our bold aspiration was to offer the single best engineering and design education experience in Canada. We also were looking at our graduate programming and looking at work integrated learning and to really become the world leader in offering work integrated graduate studies or things like cooperative education in our graduate engineering and architecture programs. In the research area, really becoming unmatched in bringing transformation from the lab to the world. And there's a number of different indicators for this in terms of research dollars being brought in, but more importantly, the impact that the research was having on our communities. In terms of our operations and resources, looking at a culture of well-being, a culture of having fun is one thing I've been focusing on, especially since the COVID pandemic. And sustainability for the future, whether that be financial sustainability, the sustainability of our buildings from an energy perspective, and things like that. And then on the reputation and outreach, becoming the epicenter of the world's technology talent. And as part of the strategic planning process, we did go out to our community to ask, well, what are the things that make us proud at Waterloo? And I would say that at Waterloo Engineering, pride runs deep, and we had over 700 answers. The majority were from our current undergraduate students. We also had alumni and other community members reply. A number of faculty and staff replied as well as our graduate students. But really, there were a couple of themes that came through in terms of learning and how they learn. How can we focus on some of the newer technologies being developed, things like augmented reality, artificial intelligence, and how can we embed some of these new tools into enhancing and amplifying the learning that is going on. The other thing I would say in the learning space was the importance of experiential learning and how this has always been something that Waterloo has led in terms of what it does compared to other universities. And experiential learning is really learning by doing. And how can we create high impact learning activities in our academic terms that really mirror this and perhaps can even bring the research we're doing more closely to our undergraduate students, because the undergraduate students say, we don't really know what research is going on here. So how can we create closer connections with that by creating some of these experiential learning opportunities that connect research to the materials that they're learning? In terms of research, it's really about upholding our excellence in research and continuing to do impactful research that will make an impact not only locally but globally as well. In terms of our physical spaces, that we should be or continue to be committed to investing in facilities that foster experiential learning and creativity, and to infuse our spaces more with our own history, with nature, and with art. And so we're really trying to shape a vision that will drive positive impact and inspire generations to come. And when we think about our strategic planning, our president, Vivek Goel, who's been in the role for just over 2 years, really framed Waterloo in terms of what he called Waterloo at 100. And this is really thinking of Waterloo at 100 years old. And Waterloo now is only 67 years old. So this is really very, very long-term planning. But what would things look like when Waterloo was 100 years old? And really, it's framed by centering humanity at the center of this and thinking about it in terms of 5 futures and how we touch and influence each of these futures. And the 5 futures include our societal futures, our health futures, our sustainable futures, our technology futures, and our economic futures. And really, when I think of the Faculty of Engineering, it will touch on each of those futures in different ways. In some of the futures, like health and maybe sustainability, it will do so in terms of the applied nature of the work. In terms of the technological futures, we will drive the development and change in some of those newer technologies by developing frontier knowledge and applying that knowledge to develop frontier new technologies. And then the connection to the economic, where, as engineers, we're different than scientists, because whatever we do, we expect to impact on society and for society to use those things. So inherently, there's a natural loop between what we do and the economic development for Canada. And finally, at the heart of everything is our society. And in today's day and age, where technology is so pervasive, we really do need to think about, as engineers, not only can we do it from a technological perspective, but also should we do it? And from my perspective as an educator, how do we teach our students to be able to answer both of those questions successfully? And I just want to thank you for coming today. Here's a picture from one of our alumni reunions last year, I think it was. You are our best ambassadors in terms of the pride you have, I hope, in Waterloo Engineering, the experience you have here, the impact it has left on your lives. And I just really want to thank you for engaging with us and joining us today. And I hope you stay in touch, and I hope to see you back at your next reunion in the not too distant future. So how can you get engaged with us? Here's a whole bunch of alumni engagement opportunities to help grow our community. You could help us hire a co-op student. We were just looking over the past 7 years, because of the growth in our programs, we now have 800 more students to hire. So we have more students to hire. So if you could help us hire a co-op student and give them a chance to start their engineering careers, that would be great. You could become a reunion class rep and take a more active role in connecting with your former classmates and helping to engage them as a group to come back and see us for their reunion. We often love to have alums come in as guest speakers. When we were running our Waterloo Engineering Pin ceremonies, we had a number of alumni come back to talk and reflect on the values we had articulated and how they saw them in their own careers and in their own experiences as students. We always need financial support. For those of you that live in Ontario, you will have heard that the Ontario universities in particular are under quite a bit of financial stress because of some of the limitations the Ontario government has put related to the government grant they're giving us, as well as the freeze and the tuition. So if you've got things you're passionate about and a difference you want to make in the world, please consider providing financial support to those areas, and we can help you realize what your own vision is in terms of impacts you may want to make on the world. You could become a mentor. And you can also become a champion for us in terms of talking about us to people in your communities in terms of what Waterloo engineering means to you and what your experience has been like it. And for more information, you could visit that website in terms of how you can get involved. And then you can follow our latest stories, on a variety of social media platforms that you can see here. All right, and I think that's it. I think I will end the presentation right there. So thank you so much, everybody, for listening to this recorded lecture now. And I'm looking forward to seeing you all soon. Take care, everybody. Thanks again.